Okay, great. Okay, today is Thursday lecture for 4/2/2020, and we're going to discuss a regular expression. Regular expression is used on Unix, Linux, and also used in Python, C, C++, Perl, Java, every other languages. Regular expression is going to help you with searching inside files or on the command line. And grep is one of the command that on Unix does a lot of regular expression search. The word grep stands for global regular expression print. And then there's a egrep for extended regular expression, and there's a fast grep, fgrep. I'll talk about all of those ones, but for now I'm going to show you some of the meta characters and their meaning inside regular expression. Let me see, people are waiting on the list. I'm gonna admit them. Okay, now everybody's here. Okay, good. Now on the regular expression, as you see on my screen, the meta characters or the encore, which is this symbol, and that one matches the beginning of a line. So every time you search for a word at the beginning of a line, you use this symbol. And then $sign is the end of the line. Dot, which is a point, dot, matches any characters. Could be a number, could be a digit, could be a symbol, any characters. Backslash S, lowercase s, matches any white space, any space that is there, tab and other ones. Backslash, notice that's a backslash, like a DOS slash, not a forward slash. The backslash, uppercase H, matches any non-white space. So it's the opposite of the lowercase. With the lowercase, you matches white space. With uppercase S, you matches any non-white space characters. The star, meaning that the pattern has 0 or more times occurrence of a certain pattern. So if it is 0 or more, you put a star. If it's a plus, 1 or more. You can see here, plus repeats 1 or more times. That's the difference between the two. And then when you put question mark right after a plus or right after a star, repeat characters, but it's non-greedy, meaning that it does not match more than once. If it finds more than once, the star is going to catch it. But if you don't want to be non-greedy, meaning that only report the first one and then quit, then you put a question mark, like almost like optional. So that is what the question mark after those two symbols are. And then here is alpha numbers, matches a single character in the list. So the list in this case is all A, E, I, O, U. And then the next list that is there is matches characters that is not matching. This encore means negated. So XYZ in uppercase is in the list, and then any matches anything that is not matching XYZ will be returned. The next one is return matching A through Z or 0 through 9. So it could be any alphanumeric character A through Z lowercase followed by one digit number that would match it. And then the next one is indicate where the string extraction is start with, and then the right parenthesis where it ends. There's also the braces that I'm going to show you more. So I'm going to include the braces as well. It was not in this document. I'm going to include that one as well. The braces is going to just show you the number of occurrence for a given string. So I'll give you an example later on with the braces. The braces basically has a left brace and then a right brace. inside the brace, if you have one number, that means match that many occurrence. Let's say you have a 5, then 5 occurrence of that um, pattern that you're matching. If it's 1 comma 5, that means minimum of 1, maximum of 5. If you leave the after the comma, the number is assumed either 0 or end of the number of as many as there. And if you just give it 2 comma something, it says minimum requires 2, maybe maximum as many as there. We will go through those examples as well. So this is one PDF Word document or Word document or PDF, a combination of both of them I provided for you. You can use the Word document, cut and paste it, and use the examples that I'm showing you tonight at the lab time. And the PDF file is good for reading, but the Word document, you can cut and paste it, and it should still have the indentation properly set for you. So it's not going to be in one line. Let me explain what a regular expression is first. In the old days, back in 90s, 69, 70s, as I showed you a video a long time ago on the first few days of the class, that was like a month ago, we discussed Ken Thompson and Dennis Ritchie, the two pioneers of C programming language in Unix at Bell Laboratory when they came out with AT&T version of Unix. Ken Thompson was writing the grep at that time because the memory was an issue that a big file would not fit into the memory. They had to filter it in one kind of like piping kind of condition. So the output of one command would be the input of a second command and so on. It would just go there, and then they use the grep command in order to just do a global regular expression pattern matching, printing it on the screen or on the display or on the file. You can send the output to wherever the standard output is, whether it's a file or a screen display. In this case, the grep command, which is the basic of all at the time that was built, it is just a regular grep command. Grep command has other syntax that later on and that was introduced. One of the syntax of grep command is the uppercase E command. Well, the uppercase E command is running like as if it's egrep, extended grep. And then there's another argument to grep command is the uppercase F that would look like work as fast grep command. The difference between grep, egrep, and fgrep is when we are going through the examples, you will see clearly how they are different. But the way it is grep is a basic grep syntax command, and it has a regular expression pattern matching syntax that it supports that. Extended grep is a little bit enhanced version of it. That's why it's called extended. It does allow you for multiple pattern matching, and it does have regular expression statement that you can compare. On top of it, it does have the parentheses, the braces syntax that you can match within one pattern a number of counts, say how many occurrences are happening. egrep supports it. The fast grep does not support any regular expression, and I'm just explaining those ones right here. The first one was the grep command, which I just mentioned about it. The second one is egrep. The egrep extended grep is supporting like braces like this, and it supports all the regular expression. And if you do the egrep and you want to match the actual pattern, you have to skip it, like if you have to use it. Otherwise, I'm sorry, on the egrep, you don't have to skip it. You could do it and it's going to work with that syntax. For the fast grep, the reason the fast grep is different from other ones is that it's called fgrep because it does a fast grep on a fast search on a string, matching a string. So you do the whole string, you pass it on, and it will match that string, and it will be really fast for it, but it does not support any regular expression. It is just basically a string matching. And the syntax of all the other ones are similar to what egrep, fgrep, egrep and grep does. Fgrep does not support any of these pattern regulation, regular expression matching. So I'm going to go through some of these examples. Let me open up the Linux machine in this case. Notice that what I'm showing you here is a little bit different on Linux versus Solaris versus Mac OS X, because Mac OS X regular expression is based on BSD, and then regular expression is based on Perl and regular expression. So the syntax a little bit, sometimes if you are working on an environment like Solaris versus Linux and one parameter doesn't work, you have to look at the consult the man pages, and that man pages is going to help you figure out why it's not working the way you expected it to work. These are the examples that I am going to show you tonight. And with each one of them, we're going to go in detail to see what the script does and why we're doing it this way, what are the pattern that we are looking for, what are the option parameters for each of those commands that we are doing it, and then the output, you're going to see it, and then so on. So in order to test these scripts, I basically and go to a Linux VirtualBox machine, which I already opened it. Yeah, it's open. I'm gonna get there. Okay. On this one, if you look at it, basically I'm on this directory, which I created regular expression, and I wrote a number of text file, a number of shell script. The first shell script that we're going to look at is called gen_infile.sh. This is going to just generate an input file for us, and based on what we are going to do. So this infile.txt, I'm going to remove it. We don't need it because it's going to be created by this file, by this script. So I want to show you what's inside that gen first, vi gen_infile.sh. This file, let me go to first line. This file basically has like a little bit information about what this shell script does. It does basically global regular expression, extended regular expression, fast. And then we could add a stream editorial set, awkward, geoc, translate, cut, and other options. A lot of those ones also does work with patterns. Translate is one of the good ones. Awk is another one, and geoc, GNU version of awk. So all of these ones are supported, but tonight we're going to do mostly with the grep command, and then egrep and fast grep, and scripts, and show you all the parameters, so you become really knowledgeable about the grep commands and regular expression. And then moving back to set, or moving to awk, and that would be the next training and the next class, and you're going to learn all of them one by one, and it's going to help you understand each one of them really in details. So I'm going to just have an input file called infile.txt. If the infile already exists, if I run it the first time, in this case, I'm doing a comparison. If that file is there, then I already created the infile and just should exit out and then don't do anything with this file. But because I removed the file, it's gonna not find that one, so it's gonna come to this else part. The else part is gonna run for a line in 1 to 3. It's gonna put 3 lines first between these do and done. It's gonna say this line number is, and then give 1, 2, 3, and then it's gonna write it to the output file. Notice that double greater sign, I'm creating it, appending it with concatenation symbol. The next one is gonna say these kind of phrases or whatever the sentence is. In this case, one of the sentences, the quick brown fox jumps over the lazy dog. The next one says Unix is user-friendly, but Unix chooses its friends. The next one says knowledge is power and sharing it is even more powerful. And then by helping others, you might help yourselves as well. That's most of the time that whenever you try to give hands to somebody else, someday you will see a benefit to yourself somehow. And then this data.txt is another file I'm just appending at the end of the input file. So before I run this script, let me quit out of it and then say cat data.txt. This data.txt, I just wrote a little bit information. We should use high performance computing with big data as the input with more than 700K. At the time that I was doing, unfortunately, there were 700K covert positive cases. And based on that knowledge, if we use supercomputers, I was thinking that we could write some kind of data science software that would analyze this kind of data. The 700 case now is more than 900, almost like a million cases, that we could just write some software, Python, Perl, Shell, Unix, C++, whatever. We just write it and run this data against all the data that is there and find out patterns of like how people got sick. So everybody that goes to the hospital, they report something. They're reporting certain condition that maybe they got it on the street, maybe they got it from the supermarket, maybe they got it from the family members. They're just reporting all those data. Those data, if we collect it for 1 million people just in the US that got infected, in the entire globe, and then maybe for each state, if we have 8,000 cases or 66,000 cases, depending on which state you're talking about, then still there's some data that we could find out certain pattern. And based on that pattern, maybe they could find, say, this is how we mitigate the problem by isolating people from each other, like social distancing. Maybe that is the best option at this time. Maybe that is one of the options. Another option is to just stay clean all the time, and then don't touch things that are a little bit risky. So there's a lot of kind of data that we can collect, and based on that data, we could have some solution. So this script, even though has nothing to do with the actual solution, but it could give people the idea what, when we are writing to data science kind of data analysis based on some data, whether it's that big data or maybe like a kilobyte of data, maybe it's a gigabyte to terabyte of data, we should be able to analyze it in a fast way of searching it. And then I was suggesting that high performance computing, because with high performance computing, parallel processing programming could be really fast. You could run on multiple threads with multi-threading operating system with multiple processor and a lot of memory available to you, a lot of processors power available, and you do some parallel computing. And instead of running it for months, you could run it for half an hour, and then you get the same data with high performance computing, rather than running it on a local machine that is not as powerful. And a lot of these data, scientific calculation formulas, people could just come up with solution easily. For example, if we have this data, maybe we could write a database that people, as soon as they go to the hospital, while they're doing all the information, they can collect the data from the user, from the person, the patient coming in. They can collect some information on another computer, which is maybe the state computer, that all they do is they say, put the information of the patient name, patient last name, address, and everything, how they got infected. Just simple question. And then save that one into a database. Now, another software could run it against that database and pull the data and does it. So today is our chance to just play around with a small data file, and that has a certain pattern. We're looking for certain string matching on those pattern. Data.txt. So if I just run the infile.sh, it just basically ran and it created a file called infile.txt just now. As you can see, the file infile.txt has the same timestamp of now, 1853, and this is the file that just was written. And those are the for statement that created these two lines. The next phrases were added, and then the data file was added here at the end. So all it is that file. If I do a cat command here, I see the file, but if I do cat -n, the line number altogether on that one is 12 lines. Okay, so now I'm going to show you a simple grep command that does look for a W, a word inside this data file. So this simple script is gonna look for the input file called infile.txt and sends the output to a grep-w, because the name of the script is grep, and then we are using the -w option. So I simply give it the argument of -w.out. It will write it. In this case, as you can see, I'm echoing some of the message on the screen, as well as I'm using the T command here that I'm writing to an output file, grep output file there. The grep output file will be written there, and then notice there's an option here with dash color. Dash color is one of the option of the grep. If I'm looking for the word with -w data inside this input file, I'm sending the output of to GOF, and then -w, if I do it in the command line, the option will just show data in red. So it will just show it on the color that I specified my grep_color to match it. Then I'm pausing it here so the user reads this information, and then at the end it writes it back on this file and it exits out. So let me just run that one. I'm going to run that one, say grep-w.sh. And notice that it pauses for me to say press enter. But before I press enter, it says the command grep-w data infile.txt is going to do this. So -w is telling the grep command global regular expression pattern that look for the pattern data and then finds a word, a complete word. If it is data with one character after, don't find that one. It has to be space, data, space. So it finds that one, and you can see it is doing that. And right here is doing the search. Wherever the word space is there, it finds it with data. But notice that because the color is outside of when you cat the file, it's not going to show the content of it with that color. So if I run the same command, grep-color -w and then data and then infile.txt, it's going to just show me in red the matching characters. If I do the same thing, let's say I change the data to, let's say, high performance computing, HPC, you can see that it is matching that one in color. The grep command is right now I'm using a pattern that is a word. So if I just say, for example, let me just show you another example. We're going to go through the detail as we go and explain each one of them. Let me make sure that no other person is waiting for me on the participant. Okay, everybody's good? Okay. So the next one that I'm going to show you is grep-wi, or this grep-word count. So let me go with this one, grep-wc.sh. This one is doing the same thing with the w does, but instead of doing a minus I means ignore case. And this one is going to do a C, meaning that how many occurrence of this data is there, does a count on them. So this count, and then cut minus n, it just shows me line number, and then grep minus w will just do a word count on it and finds out the number of it and print it out. So grep-wc.sh, and notice it says 2. If I just say cut grep-wc.out, that's the 2 lines that it found, and data was happening twice, so the number of occurrences were there, it was 2. So if I just do the same thing, like you say grep minus wc data, let me do also a word, a minus a dash color, and then find out in file dot text. Notice it shows 2, a word count of them. And then the syntax of this one, if I just look for the word high, see there's no high there, but there's an uppercase high. So that's one is 1. If I just don't want to count it, I want to list them, that one is going to show me in color a high. And if I just want to do it lowercase, it's not going to find anything. In order for me to ignore the case, I type in high with lowercase. And then wi, meaning that ignore the case, now it finds it. So whenever you're looking at grep commands, if you're looking for a specific word, you could do that. But notice if I just look for the word edge, there's more than one edge most likely. Unfortunately, there's none with edge. Let's look for a word like we, W. W is only uppercase. WI in file. Okay, so when we did this W, it did not report anything because uppercase W is not there. And even though we did specify ignore the case. So we should, okay, and file.txt, we is going to find it. Okay, so when you do this, W, the reason it doesn't find it, because it's not a word. If you just do -I, it will find all the W's. But because it's not a complete word, it is not going to find it. So in order for me to say match this one with W, and then I have to have a complete word. Like, let's say like how is going to find that with how. But I cannot just say something like this when it's not a complete word. But if I just take the W out, it's going to find the how. Wherever the slow, all those words that are 2 letters matching those ones, that will be recognized. And then there's another option is called L. Dash L is, instead of showing you the match, it is going to list the file name like that. So if I just say the argument of all files that are .text, then it's going to just find out those ones that are data.txt has that those two OW and then file.nw. So if I'm just looking for, let me just go through another example. Then once the shell scripts are covered, I'll go with more further examples from the command line. vi grep-wi.sh. wi, we just practice with that one. So in this example, I'm just searching for word, ignore the case, even though it's a lowercase I put here on the file, it's uppercase, it will ignore it, so it will just report it. And the output will be written in grep-wi.sh, and then press enter. So if I just run the same command, --color -wi, and then put lowercase hi, it is still going to find it, and it's going to highlight it in that color, matching it. If I just take the I out, and this is not going to find it. But if I just say, okay, now I'm going to just use the regular expression, and instead of this, if I just put H, it's going to find it. But let's do this. A regular expression, I could just say, I know that this much of it, find that one, but it's not a word, right? A complete word, so it's not going to find. I'm going to put either uppercase H or lowercase h, and then followed by that. That is going to also find it, because on a regular expression says it starts with either h or lowercase h. Since it's there's no other one with the lowercase h, it's going to find it. So if I'm just looking for the HPC, like for example h, and then I say PC, that is going to match the word h followed by a PC. And if I just want to say, I want to do the pattern of the parentheses around it, if I just put parentheses here, notice what happened here. If I put the same parentheses it's going to just highlight what my match is finding it here. This one, I'm not using it as a regular expression. If I have this symbol and I want to skip it, then I could do this. What will happen here? That character, I'm saying that don't match my regular expression, but match only the HPC and highlight those ones in color. So there's a lot of ways you can look for it. Like for example, let's say I'm looking at df command. Here, if I'm looking for df, and I'm just saying df -h, but then do a grep dash color, and then just search for 0 through 9. Anything that are with 0 through 9 listed for me. So all of those ones are shown up now. And then what if I want to do 6.8? If I just want to pick up this 6.8 with G, then I could do exactly like here. I could just put 6.8 G. That would pick it up, but that's not good because on the system, you don't want to go data specific. You want to just find certain pattern, saying that anything that has a number followed by a G should be reporting it. So then you could just say something like this. Let's say 0 through 9 followed by a G is going to find out all of those. But you want to just say, I want to follow, only pick up 6.8 in this case. Then you could say this 0 through 9, another one, 0 through 9, and then followed by a backslash dot. That would just, let's see why it did not pick up. Okay, yeah, this one, 0 through, 0 through 9. I wrote 9 through 9. 0 through 9, and then followed by any number. This dot means any number. You can skip it, it will still pick it up because that one is saying that the dot is just a regular part of my regular expression. So if I want to just say I only highlighted 8 G, forget about 6 point, then you could just do this, and that would pick up that 8G. In this case, it picked up a lot of other numbers that are there, and you could just say 8G, you specifically force it to 8G. There's another one for 8G. Now you just want to go 6 with a dot here, and let's see, that dot is actually matching all the numbers, and in this case you skip the dot, now it's 8G. So you can go pinpoint whatever string you do, and if you just want more than one character, for example, let's say clear screen, you say echo, this is a phone number. Let's say you write a phone number 909, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Let's say this is my string that I wanted to print out, but then I'm going to match certain pattern in it. I say grep -- color, and then I say -- color. Let's say I'm looking for 3-digit numbers, and then I could say 0. I could do it like this, 0 through 9. Just to get the numbers, I could say the area code, I could say this 0 through 9, and then, sorry, 0 through 9, that would find all of that occurrence, followed by everything, 0 or more occurrence of it, and then close it. That will just highlight those area, because I'm looking for inside the parentheses, I'm looking for some digit matching 0 through 9, but this asterisk is telling me there could be more occurrence of the same thing. If I just change that one to a brace, and I say 3 occurrence of it, 3 digit of it, is not going to find it. But then let's see if I just say 9, and I'm going to look for 2 of them, still not finding it. So this time I'm going to let's do another example here, because we already picked up the number what we wanted. So 0 through 9, in this example, I'm going to say, give me any digit. Let's see what is this does a word, and then, well, everything is highlighted as word except those dashes. And if I just want those dashes, I'm going to just say uppercase W. And you see those ones are non-alpha, non-number, and non-character. The parentheses and dashes is a W. And then if I want a B, would give me the numbers also with the characters. And uppercase B is going to match that, everything. And let's say 0 through 9 followed by one or more of them. If you do this, then 0 through 9. Let me 0 through 9, and then followed by a 0, and followed by another 0 through 9. Let's see if we could do that. I'm sure you could put the code and everything, it will still get it, but the reason it is not coming for this one, because you have to, if you're just doing the way I'm doing it here, I have to put 9 here first. If I know the digits as easy, I could say followed by a 0, followed by another 9. That would just come up here if I just don't have the slash. And then I could just do the same thing with, say, okay, so it's 3 digit, and then any 3 digit after that one, I could put 3 dots and then another slash. Let's say 3 dot, okay. This one, I'm gonna try, say, followed by 0 through 9, any number, through 9, any number, and then I could do the same thing, followed by another 0 through 9, followed by another 0 through 9, but that's redundant. So you don't want to do something like that, and instead of doing that, you just say this, 0 through 9, and then asterisk, because 0 or more occurrence of that, let's see, 0 through 9 dash, okay, 9, 1, 2, 3, 0 through 9, oh, dash here, no, 0 through 9. This one is dash 0 through 9, and then followed by an asterisk. See what is this one does? Yeah. Okay, so this one come up with the first 3 digit. Now I need to do the same thing here with this, and then followed by 0 through 9. My eyes is getting really bad when I type in these things. I cannot read it fine. 0 through 9, and then right bracket, and then at this time I get that, and star, and then right bracket, and then after that a dash. So that picked up those ones. Then if I just want to pick up the next 3, I just follow the same pattern here. After that, let's say 0 through 9, 0 through 9 with star. That would give me the next, and then obviously for the 4th, I could just do one more time. Dash 7. So 7, 8, 9, 1. I could do that pattern 7, 9, 8, 1, or cut 0 through 9 again, and then a star. That would just match everything. So there's another a nice thing about a grep command and a grep command with pattern matching is that I'll show you next. So this file, like if I was just looking for the same kind of file, all the file that has that dot text, if I have the file dir1 is also have similar files there, and I want to just find all of them match. Remember we were saying find dot minus name star dot text and then minus exact grep minus il, and I say look for the word data. I could search for it like this, and then those one will list all the files that are having it. If I just say no, show me the content of it, and instead of -l, I just say I, and then it will show me the name of the files that are there. So, and then if I just want to put here the grep dash color to get a color, I'll see that down there. And if I just do the same find command, and then instead of searching for data, I look for, say, we, it's going to just find out those words. And whatever word we look for help, it is going to do that. And then if I just say look for numbers, let's say COVID-19, 0 through 9, 0 through 9. If I just only look for one number, it's going to highlight the numbers that are 1 and 9 and 700, all of them. But if I want to just go specifically with two-digit number, and then I could say 0 through followed by two-digit, followed by two-digit. I could, followed by two-digit right here, one more. And in this case, it did not match that one. There's a single code here, nothing. It finds the two-digit, and then if I want to say, for example, let's say cat data.text, and there's here, I have some words that I say, I want to see the first occurrence of the word we, this and that. So I could say grep mine dash color, and then I say the regular expression in this case, it says start with. Remember the anchor? The anchor means start with, right here. And then I say start with the word we, and then from data.text. That's gonna just find that one. And if I say, I don't care what the word is, just find all of the words that are starting with any character. And it's gonna highlight the first character because I put the dot. The dot means any character there. And if I just say \w, it's going to do that, and then let's see, plus uppercase W. It's going to find the ones that are parentheses only there. And if I just want to do match for, let's say, cat minus n data.text. So let's say on data.text, I'm looking for the word down. The word down, I could say pipe that one, grep minus dash color, and then down, and then it will find it. But if I want to just say it ends with the question mark, and then I just put that down question mark, that would find it. If I just remove the down, it will still find that one. But if I want to just say, show me all the files at the end of the line that are there, it's going to list them. And then followed by any character, it will list those characters. So that's cat infile.text. There's another one. If I'm looking for COVID, let's say grep minus I, COVID, from infile.text. is going to find it. By default, it is dash dash color. In this example, I'm going to show you now the egrep syntax for it. So grep minus I, also the grep also has some syntax of minus e, lowercase e. And then if I just, let me just to show you the non-matching character. So if I have a file called data.txt, and then inside data.txt, I have this content, and I'm saying that show me everything, but I don't want to see the word covet. I hate covet. So if I just say, don't show me covet, and then I'm going to say grep minus v covet, and then data.txt, it is going to match everything else except the word covet there. So if I just say, show me everything about data, it will do that. Now, cat minus n data.txt. Notice that this is my file. Let me change my screen, display my prompt, echo $PS1. Okay, PS1 is that. Now I'm gonna save that one. Current PS1. Current PS1 is equal echo $PS1 and backtick. So when I do that backtick, I'm gonna save the value of it to lowercase current PS1 PS, and then I'm gonna just change my PS1 to only show a $ symbol because it's really okay. Now it's much easier to read. I'm gonna make the screen a little bit bigger also. Let me move it around. Okay, resize option. Okay, so clear the screen and then cut the data.txt. So data.txt has those information. Clear the screen again, cut minus n data.txt. Notice that I have about 5 lines in there. So 5 lines. Okay, let me just do something with this data.txt. Copy data.txt as t.txt. Clear the screen via t.txt. I want to just make it a little bit shorter. And then, so I'm pressing escape and then escape shift J. I'm going to just move it around. Let's just have that much line, those 3 lines. It doesn't have to have meaning. We're using as input to just look at it. Cut minus n t.txt. So I have those 3 lines. In order for me to show you a number of other arguments, one of the argument to grep command is the minus uppercase A command. So you already know the dash V option, grep minus a V of input. For example, I'm not seeing anything with the word input from there. Everything else is going to show. And then you already know the listing and other ones. So let me show you the dash A option. If I look at the file t.txt, I have those lines. I'm going to say grep minus A, let's say the word with. I'm going to show one line before the before it. I'm going to search for the word with. all matching the same case. I don't care with other option. I'm just going to show you that option dash A. And then say t dot text. So in this case, if I just put dash dash color, you see that what it does, it finds the width, but it also prints the second line after it. So this dash A, one means one line after the matching characters. So line number 3 is also shown here. Okay, if I want to just show you that one, I could just do grep minus n to show me the line number. In this case, the line number 3 is because of that dash A1. If I just look for another word and I want to say, show me 2 lines after the word high, the word high is going to find it, but high is an uppercase, so I'm going to put either high like this and then use the lowercase, either do it like that, and it's going to match the high. Then after the word high, it finds the next 2 lines, it's going to display those ones. So dash A means after it. And what if I want to do before it? Obviously, dash B, uppercase B. So if I just want to find for, let me do the clear screen cut t.text. If I want to get, let's say, 2 lines before the perform, I could say grep minus n. In this case, the minus B uppercase. If I wanted 1 line, it only shows the 700K lines there along with the perform, because the perform is going to be my match, and then t.text is going to do that one. So if I just put the perform in uppercase, even though it's not an uppercase, I just write it all in uppercase, perform, it's not going to find it, but all I have to do is put a minus I here, ignore the case. Then it's going to find the perform. And then and the minus B1, it shows 2 lines, 1 line before my matching. So in this case, perform was written there, it found it. And then if I just do the 2 lines, and then you could see everything, line 1, line 2, line 3 was there. But because the matching in this case is not a good example, if I just change the word perform to some, might be a good example because it shows 2 lines before some. And if I just change the 2 line to 1, only line 3 and 2 is printed. And that way I know that 1 line is before some, it's going to print it. The reason perform was showing twice. So if I was doing a word count on perform, here like the number of occurrence count, it will show 2 of them. And there's an option dash C also. Dash C is giving you 1 line before and 1 line after, or 2 line before, 2 line after, because after the C what option you gave. So in this case, let me just show you. So cut minus n t.text is 3 lines. If I want to see the word more, if I say grep minus I more, search more from t.text, it's going to find those 2 lines, that line, but I want to show 1 line before and 1 line after. So in that, excuse me, in that case, I'm going to do uppercase C, 1 line before and 1 line after. It writes all of them. And if I want to see the line number, I put a minus n here, and that would give me line 1, 2, 3. More is mashed, and then the other lines are before and after. So now you know a lot of things about grep command, and egrep is similar. So let me go with egrep. Egrep which is stand for extended grep. So if I'm looking for, clear the screen, cat t.text. If I want to search for a few comparison that it finds the high, finds the data, find the science, find the covet, and then all I have to do is this, cat minus n t.text. It will just print it and then do a egrep, okay, grep, egrep, extended grep, minus I to ignore case. In this case, I'm going to put high, I'm going to put data, and these dash, the bar or the or statement is either high or data or science. So any of those ones, sorry, any of those ones, and then find a match. It's going to highlight those ones. So if I just do that command, notice I'm going to clear the screen, cut minus nt.text. I'm going to up arrow. This is my command. This command is going to find it. But if I just change that one to grep command, it's not going to find it. Because grep by itself is a basic version of this. It does not support multiple string matching. So the egrep, extended grep, was written for that purpose to support the extended match. Earlier, when I was showing the parameter of number 2, number 3 was not working because I was waiting for you to think why this one is not working. It is because at that time I was using the basic version of grep command. So at this time, I'm going to show you a extended grep version of it, and it's going to find the number of occurrence for more than once. So if I just, for example, do this, and I say grep, the egrep is going to find it. If I change it back to grep, it's not going to find it. But notice that grep command has another uppercase E syntax, meaning that use the extended grep, which is egrep. So I could do that and it's still going to find it. So that dash uppercase E, which I told you at the beginning of the lecture, is an option that tells the grep command, use the extended grep command. Now the regular expression with multiple arguments are going to be found. That's a nice thing that they added on to the old version of grep command to be upward compatible. So it does support it. And then I'm going to show you another command. It's called fgrep. So let's say I say cat t.text, and if I say grep command, I'm going to say grep the data, is going to find it definitely, right? It's going to report it that those are there. I could also use the egrep for that because that is just a string. And I could also use the fgrep. Fgrep for fast grep. Fast grep is much faster than egrep and grep in this case because there's no pattern matching. There's no pattern that says if the person, the data was there. Now watch if I just do this one and then I say, I don't know if the letter is A or D, but find any of those two. Now I'm using a regular expression. I'm just saying that there, because fgrep does not support regular expression, it's not going to find it. So if I just take that one and out and say use the grep command, now it's finding it. If I take that one and say do a egrep, it's going to find it. If I did a grep command with uppercase E, which is extended group, it's going to find it. I do a grep command with uppercase F, which is a fast grep, is not going to find it because that's a pattern, a regular pattern. If I just change that one and I put the word data here, or that, it's going to find all the words that are there because I'm specifically searching for a string. So that's the difference between grep command, egrep, and fgrep. Fgrep only matches for a string, and then that string, because it doesn't do any regular pattern matching, it's much faster. It does not do any computation on regular expression to match it whether that pattern is occurring or not occurring. But it only looks for a specific string. That's why it's called fast grep. And then egrep is an extended version of grep command that support regular expression. And with regular expression, the escape sequence you can do also with that. So let me show you another option of the grep command and egrep command that are really handy. So if I just say, look for data here, this is gonna find it. I'm gonna try this. I'm gonna say, since they're not in the same file and two of them, and minus uppercase E, is not going to find it because inside the data, so let me modify the data. I have to duplicate the data somehow a number of times, certain words. So I'm going to put word here, data, and perform and data. So like if I just have a number of things inside this file, now if I search for data, it's going to find a number of them. In this case, I'm going to go back to my example of extended grep and say, find the data. This one, actually, if I just do a word count on it, minus word count, is going to give me a count of 2. But data is not written twice next to each other. So if I just go and modify the t.text and I write data, like for example, twice next to each other, and I write the word, let's say, test, ttt, and then test tt. Now multiple times I duplicate something. So if I just now search for the word t, and then I say, show me t more than at least 2 times, and it's going to find this is 2 and then more than 2. If I just say no, show me 1 time t, it's going to show all of the one that is occurrence. So show me 3 times, the 2 times are not going to show me, and the ones that are only there. So data, if I just change that to data, only happening twice, but not 3 times. Let's see. Yeah, only 1 time that is data together, and every time else is here. So if I'm just looking for a specific word, like let's say the word, that one is not, it's happening only once, but they're separated. Now if I just change that one to t.text, and I just add some lines here, word, ding, whatever, it's still the word is going to find out that option there. I'm sorry, this doesn't make any sense. Word, okay. So what, t.text, let me see the syntax. Okay, word. Oh, the next one I'm writing it incorrect, the typo. So the typo is because I wrote it like world, completely there, different. That would find it. And if I vi t.text and modify it, correct it, and then correct it here, and then search for word, and then occurrence of 1, it will just find those ones that are there. So now notice that this is the option of egrep with this number pattern matching. If I just don't put this one and I use the regular expression, it's not going to find it. But whether I put the dash E is going to find it, or if I put a basic regular expression, is not going to find it. If I use the egrep, is going to find it. If I use the fgrep, is not going to find it. If I use the fgrep, the egrep with dash F, is not going to find it. So that is a syntax with the braces is only for extended grep. So change that one to extended grep, you will find it. And then change this one to egrep. Take this one out, you will find it. There's another syntax of the grep command with the dash lowercase e. So and the way you find out all these syntax, you just do a man on grep command, and it tells you that the grep option, pattern, and then file. And lowercase e is the regular expression pattern that you could type it in. And right here is extended regular expression with uppercase F for fix the string, fast string matching. A string is fixed always. It's not going to have any pattern regulation. And then a fast grep command will do that one for fixed a string. And then the lowercase e was also for regular expression for it. It should show up somewhere there. Minus a minus e text binary minus the action. And then here, and these ones, you know it, like for example, we talked about the question mark that matches one character, asterisk 0 or more occurrence, plus is 1 or more occurrence. This n, the preceding matches exactly n times. So we were giving exactly 2 times or 3 times. N comma whatever, the preceding matches n or more times. More times as many as they are. And then when you are leaving the blank comma m, it starts with whatever the matching were at that time. The preceding item matches most at most m times. So 0 or 1, if m is 1, 0 or 1, or 0 or if m is 2, 1 or 2, or as many as m times. N and m is 1 to the minimum or maximum a number of times. And then the braces we use with the numbers, and then left parentheses we used with the phone numbers, we use that one. You could search for it. And the grep color is a set of parameter that sets it. This option is not on Solaris, for example, on the color. You have to download certain version of a grep command, and it does support it. If you just end up not seeing it, just do a grep dash uppercase V, and it will tell you what version of grep command you're running. In this case, you can see I'm running GNU grep command 2.0. So the GNU version, which is part of all the other utilities that we are talking about it, and this class, including bash, is a very good example of indication of what grep supports and what it doesn't.
Professor, I think a student is trying to connect right now.
Okay, thank you so much. Let me look at it for the participant. Okay, yeah, thank you. Matthew is there. Thank you. Was that James?
Yeah, that was me.
Yeah, thank you, James. I could recognize your voice. A lot of you guys are having a distinguished voice, I can recognize most of you. That's a good thing. Um, some of you guys forgot to submit, a few students forgot to do the assignments. So I end up asking the person or the couple of people to just submit it. And I'm giving you time till next week. Please submit it by next week so I
It's
could
just
check.
the 3 assignments so far, correct?
Yes, the
Okay,
assignment,
thank you.
we already did it, everybody. Assignment 2 was there. Assignment 3 is basically the replacement for midterm, right? Or there was more assignment? James?
As far as I know, there was only 3 assignments, and then the one that we have to turn in next week.
Okay. There was one for the assignment that I was asking you guys this Tuesday to just submit a one paragraph page to just say what project you are planning to do out of those two options or whatever you're planning to do. Just let me know. Some people already told me, some people have not. But if you have not told me and you're writing a program or choosing one of those two options, that's fine too. But let me know if you're not getting one of those two options and you're writing a specific kind of set of project that you think would benefit you at work the most, then just write like half a page paragraph to me. Say this is what I'm planning to do, and I'll approve it, and you can work on it. Because some people they change their mind and they're going back and forth, and I want to make sure that you have enough time before the 9 so you can finish it up. Okay, there was another part of it that I'm going to show you some regular expression in Python. The reason I'm covering that one in Python, I told you that with this class, we can cover you a lot more than just what the book is talking about, because I already gave you so much of uh, command line syntax and scriptings, environment variables, and if statement, for statement, while statement, looping and iteration, and examples of programming on the web and programming to create files on the fly, and at the same time, a lot of commands. At the meantime, sometimes I want to just give you a little bit more ahead of this class, just in case if you are taking another class and you should be familiar with the idea of, oh, I learned a regular expression in Shell, I don't know how to do it in C, or I don't know how to do it in Python or Perl. They're all similar. The syntax of regular expression is the same thing. The function or module that you load and use it is a little bit different. So in that sense, I'm going to cover a little bit Python programming with a regular expression tonight. So let me just do that right now. In this case, as you know, when you're in Unix, in this case, I'm on a CentOS machine, etc os-release, as you all can tell, is CentOS 7, which means that there's systemd configuration for it, and I can do a lot of things with systemd. One of them is, in this case, I want to know which Python I have. So user bin Python dash uppercase V is going to tell me the version that I have. And then dash dash version is also going to tell me. If I just run this one, it's going to jump into Python interpreter 2.7. At this time, I don't want to use Python 2.7. I want to use the later version that is better, because 2.75 is already deprecated, with version 3 is available. Actually, version 4 is available, so I'm going to use version 3. In order to do that one, if I don't have the package Python 3, I have to install it. So I went ahead earlier today, I installed it on this machine, Python 3. And the way you do it on CentOS, you just become root. Um, actually, let me become sudo, or maybe root, that's fine. Just become. Okay, so I'm right now root with sudo access to the server, and if I just say yum search Python, this is going to find all the Python that is available for me and the one that are already installed on the server. So there's a lot there, but I'm not looking for Python 2, so I'm going to look for Python 3. If I look for Python 3, the modules that are listed is going to just show me that these are the Python 3 modules that is available for me. So since I install it, I say which Python 3, it already shows there. If I say RPM minus QL, maybe I don't have it. That's a good thing. I must have installed another machine of mine. So Python 3, I don't have it. So I'm going to install it. Yum install Python 3. And then minus Y for yes to not prompt me for installation, yes or no. So it's going to give install Python. Yum is the yellow update manager, yellow dock update manager, which is the kind of repository tools for Red Hat package manager, RPMs. It just looks for the repositories and it is going to find that one and is going to install it. Equivalent to Yum and Solaris is PKG for package. And there's on Solaris, the Spark architecture is package add, package remove, package check, and so on. Package and for installation, package parameter for parameter. And then for the Ubuntu, it's apt-get install for Debian apps apt-get. For this one is Yellow Dog Update Manager. So in this case, I just installed Python 3, and this is the package that it gets installed right here, Python install 1. So if I just say RPM minus QA Python 3, it's going to just show me that that's the RPM that's installed on my system. If I want to list them, I say RPM minus QL is going to list all the Python on there. Notice PyDoc for Python documentation is there, which is also binary and Python environments. So how do I know those are binaries? I could just say while read var do and then file and then $var and then done. I know that they are executable files so for each one of them. So in this case, if I say which Python 3 is going to show me that, and if I just do this and let's say grep minus I ben, remember that grep command with regular expression? So I say show me all the binaries that are installed on user ben directory. Since Python, if I do which Python 3 is going to show /ben, if I go ls minus l ben Python 3 is going to show that that's a symbolic link to the Python 3.6. So when I say Python 3 dash version is going to tell me the same thing, or dash v and dash uppercase v is going to show me that one, or /ben Python 3.6 dash v will show the same thing. If I just type in which Python, because that one is Python version 2.7, now I need to create an alias at least for this session. And if I want to do that session to update it on my system, there's a file in my environment. For each environment, you have a .bash or C. Inside there, you add the alias for it, and then it will be a Python 3. So in this case, I'm going to do it only for this session. Later on, I could do it for wlitfree if I want to. And then what I do is say alias Python is equal Python 3. Because when I say which Python 3, it's already finding the right one. So now if I say alias Python, it's going to say that that is the case. So all I have to do is type in Python dash uppercase B, it will just say 3.6. And then if I just say Python by itself, it's going to go to 3.6 interpreter. At this time, I'm inside Python interpreter. I want to give you a little bit information about the Python interpreter before we write a bash script to do it. So let me just say dir here. If I say dir, these are all the modules and all the magic methods and other parameters or properties and attributes that are defined. In this case, is all it is I don't have anything loaded except the magic methods. These are like underscore doc. For example, say dir dot underscore doc underscore, it will just tell me the documentation on it. And then if I just want to do something else, it will show it. So at this time, I'm going to import a regular expression. Now I did this command import regular expression. I just loaded the module called regular expression into my previous environment. Let me exit out of this without doing that. I'm gonna try clear screen, run Python. I'm gonna do dir first, show you this. There's no regular expression here. Now I'm gonna do import regular expression and then do another dir. Notice that now I have a module called regular expression in addition to that one. So if I want to just get the all the modules and methods and attributes of that regular expression that are loaded, I could do dir of regular expression, and it will just show that what are the methods that are available. Okay, the methods that are available is a number of them. One of them is find all, like this find all. This is one method, and you can see if I just say the word instead of dir, I could say type. It will say this is a module or find all, and no attribute find all. So I'm gonna just use it as a method, and that find all. Let's see, a regular expression find all. One second. Help. Oh, so when I imported it, dir of regular expression has that these methods, but then dir dot find all is there. See that dir dot find all is going to say find all has these other methods that are there. All of them are a magic method that are like equality, document, directories, dictionary of it, size of, and everything. So I could get certain parameter for them based on what I'm looking for. So at this time, if I just do help on dir find all, it will tell me that find all is a method that requires 3 arguments. One of them is a pattern for a pattern regular expression pattern. One is the string that I'm matching for, and then the other one is flags that I'm setting for, or whether the flags are those uppercase E, uppercase lowercase e, or -n, or word or something. Those are the flags. So in this case, if I just create a string 1, and I just say, and this is a string that has the data which I need. and I put some number like 55, age is equal 55, let's say. And then I just created that string in Python. If I say print a string, I'll just print the value of it. That's there, print the string, and then, sorry, print the string one, I'll get it. Or I could just say string one, it will just do the same thing. So if I just want to get the content of each of this string, it's like almost like an array. I could say print 0 through 4 or 5. This will just print string 1, 0 through 5, the word this. And then 0 through 4 is exactly the word this. And then if I just leave that one to length of the string 1, and then that's still gonna print me up to the end of the line, almost like leaving it blank with the other example. If I want to just get certain information on that one, notice that the dir of a string 1, it tells me more arguments, more methods that are available. With those, that string 1, whether I could do append to it, replace certain character with it, change the title, change it to all uppercase. Everything is, Python is functional programming as well as object-oriented programming. So for example, that string 1, if I want to just say, print the string 1, and now I want to change everything to uppercase. All I have to do is call the upper method, which is part of these methods that are available for it, and it will just change that one to uppercase. If I wanted now to change it to lowercase because it's object-oriented, I just change everything back to lower, that same method. So now I'm inside the string 1, I'm going to do some regular expression. So I say string 1 is this. I want to search for it. I say import regular expression. I think I already did that one, draw of regular expression. Yeah, I already did that. So if a string 1 has this one, I could say import, not import, I could say regular expression dot search, for example, the word this, and a string 1, a string 1, and then just search it. Notice it told me the object it found on between 0 and 4. If I just look for a string, the word string is going to say 10 to 16, which means if I used a string 10 colon 16, then I'll get the output string from it, string 1. So if I'm looking for 55 on my match, on the search, I'm just putting the word 55 is equal 55, let's say. And that's 3-digit number, 52 through 55. Then I could say a string 1, and then print 52 colon 55. That would give me exactly is equal 55. But I could also find the same string using this one. And instead of doing that, I could say find all. Find all is going to find as many occurrences as are there in each one of them. So if I look for the word S, because there's a lot of S there, you can see that it's going to find that one. So let's say is going to find the numbers there, find all. Now, let's write this one into a Python script and then get some information from bash to just generate this one. Type of a string 1 is a string. Okay, I'm gonna quit out. Okay. So I'm going to write a Python script called vip1.py, and then I say slash ben python. If I forgot where it was, remember on the VI, you could say escape, bang, shift colon, and then bang. I could say which Python, it will tell me the path, ben Python. And then I go back there and I modify it. Then I could say import regular expression and then define my string one as equal, and this is a simple test and some numbers, 1, 2, 3, whatever. I write that and then I say print a string one, and then I could say, since I'm inside this bash, this one, if I just want to do this one instead of printing it like this, let me just put some a meaningful number, 55, and then end. So I go like this, and I could just say print string one, and that would just simply run it. Say change mode 755 p1.py. Remember when we were doing the first line, if I say head -1 p1.py, the first line I'm having this one, that means the rest of this p1.py has Python syntax. So if I just say p1.py, since I made it executable, it just wrote that statement. Now I'm gonna vi p1.py say, yeah, I printed out, but let me just print it one line at a time. So I say for line and string one, and then one. And now in Python, in order to do this one, as soon as you start a for statement, you have to indent it. And in bash scripting, you could use do done and all those things. Here, you have to indent it. So 4 spaces, 1, 2, 3, 4. And then I say print, in this case, a string, one line, and okay, done. So in this line, if I just say p1.py, it writes the first line statement, the whole thing in one horizontal line, and then the other one is going to write each character on one line at a time, right? So if I just say p1.py, and I want to say, let me make this one a list, okay? If I just make this one a list, now it's not one character line, it's a list of these numbers, okay? I could just put, this is one string, and make up to here, let's say, one string, and then this one another string, and then the 2-digit numbers are separate, and then the last one is another string. So if I just do this, when you define a list in Python, you have to separate them by comma. Each of these are element of a string, element of a list in this case, will be printed the way you want it. So now if I just do, instead of print it, I say, yeah, print this one. But this time, if I just do type of this one, it's going to say this is a this is a list element rather than a string element. Notice it says this is the list, and then this is a test symbol. And where did I print my vi p1.py? So here, when I say type, I have to do a print. This is gonna say This is a list element. Sorry. Okay, now I run the same thing, and then it says type is a list. Notice that this time, because it is a list, it was not one character at a time. It printed out as a list. So for each of these ones. And if I just say vi p1.py, and I could say right here when I'm looking for it, and then say f, let's say the word, I only match certain words. If I say f simple and line, then print it. Otherwise, you don't print anything. So in this case, I'm just saying if the word matches a simple in line, then print it. Otherwise, don't print it. Okay, print line is not going to find it because of the if statement. Remember the indentation, this one has to be indented with if statement. So 1, 2, 3, 4. Every time you use that colon, you're using a selection or a looping, and then you just have to indent it. So now I run it, it just says list is a simple test. And then the next one is if statement, it failed. Argument of type int is not iterable, right? So VIP1 dot pi. Right here, the 12 in numbers, those are integer numbers. They're not iterable, so that makes sense. What I could do is do a string matching. If I don't do this, then I say for a string and casting it to a string first, then try it. Let's see. Can't assign a function call a string line and string one. Okay, so that makes sense. I'm gonna just take this one out because that's the line. Here, this one is a string iterable. Yeah, so it finds that word. If I'm looking for another pattern with a regular expression for it, then I need to do a find command with find all or regular expression match. So let's do this. And then I say if this is in the string, I could say if, and instead of a simple match like a grep command was doing it, or fast grep was doing it, this not in statement, those are like similar to a pattern matching with only one string. But I'm doing a regular expression now match. So if I say f regular expression dot search, and then inside the search, I'm going to put a pattern. I'm going to say, let's say a word, and then let's see what that finds it. In line, then print that line. See that pattern is matching everything because all the words are at least either alphanumeric or the digit. So if I just go change that one, I'm going to look for a space only. vi Python. And this time I'm going to look for a pattern of a space only. Backslash a space. That's my regular expression. Notice that even though there's a space in each one of them, as it finds a space in the word, it finds it and it displays it. Now I'm going to look for a digit, vi, and then I'm going to say search for, oops. So if I look for a digit, yeah, digit is going to show only the 1255 that are matching those ones. And vi, so I'm going to look for and with dollar sign at the end of it. See if that finds it, because it's not end of element, but it's end of the last element in this case. Yeah, it finds it. And then if I search for the first line and say and core, and then this is going to find that. I run it. There you go. So we practice a few of them, but now what if you just are using a bash script to call this Python script? That's so simple, right? So inside bash script, you have this Python script, something.py1, p1.py. If you look at this one, it does have already the syntax of Python and it does certain things for you. And let's just add one more thing to it, vi p1.py. And I'm going to also do right here, I'm going to say regular expression dot find all. And then I'm going to search for the word hand some numbers. Doesn't matter what I wrote there. I'm just looking for that same word. I'm searching for that word. And add the pattern called string one. And then I'm assigning that to a new string, say called new string one. And then once I found that one, I'm gonna print that one. Print. This one I'm gonna get an object with where that string is found in this the global string one. So if I just run this and then run p1.py, okay, so it has a traceback error. Why? Because handsome regular expression line once and find all compilation file, find all string, expected string or buffer. So let me just see why vi, and in this case it is having issue because of these. I'm just looking for one string because that other one is the spaces and it's gonna just skip it. We have to do some other regular expression with backslash s in between. Let me try this first. Find all string buffer. Okay, so find all play new string regular expression, find all numbers and string one. Yeah, that's the problem. Clear the screen and then run it again. Save it, run it again. Um, so find all numbers, string one. Recent call, traceback, most recent BI line 13, P1, P1.5. Line 13, let me just do set list, set new. So we have line 13. There's something wrong with that line right there. New string one is equal regular expression dot, that might do it. I just had a typo there. Line 1, line 13, VI, find all string. Oh, okay, okay. So when I was inside the Python interpreter, I was already pointing to it. This time I have to do a little bit different. So I have to do a string one dot this and take this one out because I'm looking for this number and I have to use it similar to like object-oriented method. This is my object. I'm using the find command on it to search for it, and then I'll print it if I find it. Okay, regular expression. Yeah, I have it a little bit off here, so let me correct it. This is a string one, regular expression dot find dot a string one, and then that method. That would work on it. See, the syntax is making sense this way, but why is it not even showing up this way? New string, regular expression one, function object has no attribute string one. BI, let me see, Python, something I'm typing error. So string one is equal, and this is a test. Okay, and then I say, oh, because the other one is a list rather than a string. That might make sense. Okay, so a function, I have it now as a string. Then I say import regular expression, import regular expression dot find all, and then I say, but it was, this is a test. What did I name it? Yeah, this is a test. Okay, so I'm looking for a test inside a string one, and that would find it. Yeah, it has to be a list rather than a string. Vi p1 dot test dot py. Okay, and then I say string one is equal, and this is a list of strings with numbers and okay. So let's do that, and then this one will say it's a string type, and then for a string I don't want to print it for line in a string one. If search of this is find out, then print it. Okay, let me see if there's no problem with the first for statement. The second one should be okay. Clear screen. P slash dot slash p1 dot py. Okay, find all is still on the problem. Yes, because I did not correct the vi p1 dot py. and then search for a regular expression right here. Okay, and then find all and string one. Yeah, so that was the problem. Let me cut p1.py and I explain why that was a problem. So when I was using it as a list, this list is a different data type. This is a different data type. This is a string. This one takes by definition a string uh, that matches against another string. So if you say this is a string and you're looking for a object of type list, it's not going to find it. That's why the backtrace was coming. Because of this fix, now I define the string one as a string, it found it. And then the result here, p1.py, it shows the type string is a string, and I was looking for the word number here, and it found it. And so let's now change that one to a bash script. In order to change it to a bash script, all you have to do is say copy p1.py as p1.sh, vi p1.sh, and then here you don't need to do any of these ones, okay? Since it's already there, you just make a call to that bash script, and then here you just use the bash, and instead of Python you just say bash, and since the Python script is there, you could say that this is simply calling the p1.py script, and then you could call it a number of ways. You could say dot slash p1.py. Since it's already there, you could run it like this, and then p1.sh, it will already run it for you, and it gives the output on the screen. So sometimes a Python could return a result, and the result you want to save it into a file. In that case, you have to write a function in Python, and that function returns the result, and then you restore the value of it to another script. Sometimes you could say, well, let me just do this one, the output of this one. If you're looking only for numbers, in this case, you could say vi p1.sh, and I say send this output to greater sign, let's say t.p1.out, p.1.out, and then grep minus I for numbers. And then since you're only looking for that word numbers, you could do that from only get the numbers, send it to p.out, and then say what if I want to print out the p.out, cut minus n p.out. I know that that's my output. I could say p1.sh, and basically the number is there. This is the list of a string with numbers and line number 2. So since the word I'm looking for numbers, it is showing both of them. The first statement and the second statement. If I want only to get the bracket of obviously with a statement here, when I'm doing that, I could say grep minus I and then do some sort of string matching. I could even do this on the grep command automatically. I don't have to skip it, I believe. That then the first line will not be printed, the second line will be printed. This is a list of string numbers. So inside the p1.py has this is the same, yeah, it has the bracket here already. So it picks up from that one also. If I go p1.sh.py and take this one out, let's see if this time, and this is a string of numbers and okay. So the first line, if I just don't want it, again your grep minus v will just take it out. Or I could do p1.py. No, I'm sorry about that. So you say vi p1.sh, and then where it says numbers, you could just say match exactly that word. So the other ones are not gonna be there, and run it, and it says this is simply the call to the script. If you want the other one, you could also do minus v. Let's see if that one picks up the other one. Yes. No. p1.sh. What am I looking for here? p1. And then I'm gonna do search for backslash this and backslash that, matching exactly the same thing. Pattern matching. Let me look at the file one more time.
Professor.
Yes.
Check to see if someone's coming in again. Sorry.
Thank you. So participation management. Okay, thank you. So this is P1, okay, cat P1.py. So we did that, and then that returns the result. P1.py gave you P1.py gave you that, and I wanna only get the last line, so I could do this. P1 vi p1.sh, and I could say tail minus 1. No, since I'm only looking for the last line, I could pick up there. I don't need to be too specific on that one. And then clear screen P1. You notice that how many ways you can do certain things. You could just only pick up and then now P1 dot out. What did I name it? P dot out? Something dot out. Yeah, P dot out. P dot out is only having that one. The script is still sending that information, because I could send the script's output to standard error or standard output, or how I want to redirect it. But since I wanted to write it into p.out, and then p.out, it has that one, vip.sh, sorry, quit out, vip1.sh. If I do p1.sh here, and I just don't have to do this one, even on the screen, I don't need to see that one. So all I do is p1.sh, and it will just tell me numbers, and cat p.out is there. And then that one was coming as a result of p1.py. So I was only looking for this output. Sometimes you're looking for a function that returns the result, the square root of a Python program, and then you just want to calculate like a power of functions or something. then in that case, you just return it to get only the value of it. Let me show you one example like that for Python. So if I just say vip2.py and I say pound slash bin slash Python, and then I say import math, so I import my math module, and then I say print, let's say power of 2 to the power of 5, which is 32. And then print that one, a simple Python program. Now change mode 755 p2.py, clear the screen, p2.py, it just import command not found, vi p2.py, syntax error, and import math python slash bin. What happened here? Import Python, import math. Oh, so import should have worked. So math.pow is there. p2.py. Import command not found. Why not? vi p2.py import math. Set list. Make sure there's no invisible character there. That import should work. p2.py import command not found. Syntax error near unexpected. math.pow. So cat p1.py. Import regular expression works there, but import this vi. Somehow my Python is there p2.py. Python. Which Python? bin Python slash bin Python. Let me see, Python 3. .py Python 3. I want to see why import is not find math. Yeah, it does. Import math, print math.pow of 2 comma 5. That's 32. And 2 to the power of 5 also gave you 32. But vip2.py. So I'm gonna try and not use that import function. It doesn't make sense, but I could just say print 2 to the power of 5. p2.py. Yeah. So unexpected token 2, line 7. There's something else is wrong here. vip2.py. def p2.py p1.py. p1.py to p2.py. Yes, vip2.py. I'm gonna try. So import math. Math. Just see what's going on here. Okay. vip2.py. Now it works. For some reason, there must have been some invisible character there. Print. If I'm looking at all the thing here, and this should print out the result p2.py. see, vip2.py. I'm gonna comment out this line and say print power of, okay, math.power of 2,5. Okay, dot p2.py. That gives you 32. So some invisible character that was there earlier. I'm gonna do a square root of 25, let's say. A square root of 25. Instead of showing this, I'm gonna get 5 for this one. And okay, so now I say vip2.py, and I'm gonna put one of them into a power function to the power of 5 is equal that. And then this one I could say is square root of 25. Square root is equal that. Then I say print to power of, and let me make it simple, 2 power of 5 TPOF 2 power of 5 to power of 5, and then print square root. So I got those one values. Now I'm gonna do a print of them, and then at this time, what is happening here again? vip2.power mark.power of that. Yeah, there's 2 arguments, so a printf statement. I took it out. I need only one, because the power is in one method, and that's all that is. The square root of the same thing. So now I get these ones. I could just return those values to like a script there, and then if I just make this one as a function p2.py, I could make a function. I could just say def tpf as a function, and then say return this as a function. This is for that, and I have to go 1, 2, 3, 4, and the same thing here. And instead of this, I could say def math function. Def instead of that, I could say square root. Let's say tpf, and I'm gonna just make it shorter. T and sorry, that's it. TNS, just short function name, and then def square root return 1, 2, 3, 4 return. In this case, I could just call this methods later with return that, and instead of giving this, I could say n, the number that is passed on. So return and that, sorry. A position parameter. So in the first one, I'm gonna say print t of 2 comma 5, and then here I'm gonna give two parameter called n comma m, and then here I'm gonna just say 2 comma m, and n is fixed. N is equal fixed. So I'm gonna give that as a value of this as fixed always, which I could put n, and then m is passed as 5. So it takes only one argument, the other one is default. And I could even do this, since it's already default, the default is first and then the position parameter there. I'm gonna just take the default value, see, I could try both of them with the number I want. Okay, 2, 5, and then return square root of n. So now t25, and then here a square root of s of n. So this is the Python script that would do those two functions. Call them here. The definition is up there, p2.py, and then 32. So now the next number was n is not defined. Vi, okay, p2.py, yes, n has to be 25 here. I could just even say n is equal 25. Okay, I could do that, or I could just give the 25 inside here when I pass it with the argument. So this would use those two functions p2.py, and it will return it. Then I could write another script to just use these parameters and head -1 for the square root and head -2 for, for power, and head -2 with this. So like, for example, I could say head -1 would give me the first number, tail -1 of that one would be the next argument. I could just run the script and then just give the arguments to that one, then say the square root of 25. So if I just write up vip2.py, I could say ben bash, and then say, get rid of all of that, and say, the first one was power. So I am going to store that into a variable power. I say p2.py head -1. I get that one into the value of it, and then say echo the power of 2 to the power of the 2 to the power of 5 is equal $P. So that would print me on that. And then the next one, I'm going to make the same call again here. And this time I say tail -1, store it into the square root, and then do another echo, and then say paste the square root of 25 as s, and So now my first program, Python, is doing the calculation. My second program, shell script, change mode, vi, okay, which bash, bin bash, vi, p2.sh. What did I name it? tr. Oh, I hope I did not name it the same thing. I think I overwrote it. Yeah. That's suck. See that the naming was bad because I named the same script with this. So I'm gonna just move the p2.py to p2.sh and rewrite the p2.py. So that one is there. I have to rewrite the functions, so it's not a problem. vi p2.py. I'm gonna say #bin bash and then say def t and n comma m, and then 1 2 3 4 return t math dot power of 2 comma n comma m, and then import math here, import math. Here this one is Python, Python 3. Okay, math, and go next line, import this. Okay, 2yy, 2yy, and then paste it here, and then call this one s, then square root of n, math dot square root of n, and now I'm gonna call it as t of 2 comma 5 and s of 25. Okay, so let's just run it first to make sure that p2.py is okay. Change mode 755 p2.py. p2.py is okay. No, what is the problem? Return is wrong. vi p2.py. Return is mistyped. Return and then return. Okay. Now run it. vi p2.py and sorry, just that and print this one. Okay, clear the screen. p2.py, cat p2.py. So our Python script is working. Now cat p2.sh bash script is the same thing. It's calling the p2.py. So we say p2.sh. It does the output. So let's see why the command not found. Line 3 p2.py and line 5 p2.py is not found. vi p2.sh, where we say this one, we're gonna say / run it and / run it. Clear the screen, p2.sh, it is there. So the 2 of the power of 5 is 32 and the square root of 25 is 5. Notice that here are the examples just to clarify. p2.py is this script. If you run it, it's two functions that takes, one of them is 2 to the power of 5 as an argument, and then it returns 32, and the other one is square root of 25, 5. And then if you run it like this with pi, it will just give you that one, but p2.sh is a shell script. It makes a call to that one, takes the first one as argument of it and assign it to a p, then it prints it, and the second one as a tail of it as argument, and it prints it to that one. So p2.sh will just give you that result. So now you integrated a shell script with a Python script there. And you could do the same thing with other ones, that as long as it is a function that returns a value, remember that echo $ question mark is always returning either successful or failure, and from there you can just understand what you're doing. The rest of them is easy. So I showed you today a number of scripting. Sorry for the some of the typos, because sometimes I was creating it on the fly, and as you talk for hours, which I have been working full time during the day, and at the same time doing this, it's not like sometimes you get a little bit tired, and my eyes are sometimes not seeing the characters properly, unfortunately. But it is a good thing that we still got it working, and everything is there on the lecture. When you listen to it, the parts that I just was like trying to figure out what was wrong, even though the pi2.sh, for example, but .py, and somehow the import was saying that it's not recognized. So the way I fixed that one, if you just don't find any issue with it, normally you open it in VI, which I didn't. You open it in VI and you do set list. If you do set list, all the characters that are invisibles, it will show. In this case, there's no typo or anything there, so it should just work. Somehow it was not working, so I did an easy way to do it. It's copied. I think maybe because of this was Python on just itself, it was using version Python 2. Let me see if that was the case. p2.py. No, p2.py is still with Python 2. Python is still referencing the Python 3 because I did an alias earlier. So in Ben Python version 2.7. That one also works with math. Math is a standard library. You don't have to do a pip install on it. Pip PIP is a Python installation modules for all the Pythons that are not part of the standard modules. You could import it. So like, for example, let's say NumPy, if it is not there, if I just go to Python here and I say import NumPy, it may just not find it. Then I have to do a pip install on it. Pip install NumPy. And then say Python -m for module, and then pip install NumPy. That would look for a module called NumPy. It will install it using the module called PIP. -m means use the module pip, install as the argument to pip, and NumPy is the module that I'm installing. So I still have to have the Python interpreter to just use the module Python pip. And then now NumPy is there. If I just say Python, and then I say import NumPy, you can see that it's getting imported. Thereof NumPy, all the modules, metrics, and arrays, and all the other methods with NumPy are available. So many of them. earlier I was showing you an example of list versus a string, and uh, our class we are using array as a string. In array we talked about associate array versus index array. In Python there's no such thing as array, but NumPy has an array structure. And then the way Python is, it has a list. A list is one data structure, set is another one, a tuple is another one, data dictionary is another one, and then class is just a class as object-oriented part of data structure for it, which is a blueprint for an object. In this case, if I'm just using, for example, a string, I say string 1 is equal Wahid. Now, if I just say type string 1, type string 1, this one is a string object versus a list, which I say array of numbers 1, 2, 3, whatever number I put. I could put this or test. These are also acceptable. This is different than set. Set only requires a particular number and cannot be duplicated. And then on the test, I could have multiple numbers that are duplicated. It doesn't matter. If I just say like 23 here is one element, and then the 23, the first one on the first element. So if I say L of sub 1, and then I'm going to get the list of 23. Then this is 2, this is 3, this is 4, this is 5. So L of sub 5 is also giving me 23. And L of 4 is going to give me test. And then this one, if I type in type of L, L is my element, is a list. If I have it a tuple, let's say tuple, and then I say tuple is defined with this syntax, and this is, and then 1, 2, 5, whatever. I have a tuple, then I just print that tuple. If I just say type of T is a tuple. And then the other dictionary data type is a dictionary, which is, if I just say dictionary is equal, let's say the dictionary name is like this syntax, is a string name, colon, let's say call it first name, colon, and then the value. Remember the array, associate array? This is based on the associate array, which is a key pair value. So the first name, and then I have a value for it, Wahid. Then comma, the next keyword on the things is last name. Last name is a keyword, and then the value of his Lutfi. And then let's say title. And then I could just have, let's say, professor or instructor. So I have this values. Now I'm closing this dictionary. I just defined that dictionary. So if I say dictionary of the keyword, remember the keyword that we were typing F name here? Now I'm getting that. And if I say last name, it's gonna give me the value of Lutfi. And if I just say, give me the title, and then it's gonna say instructor. And I could also do this for, let's say for key in D, and then I say 1, 2, 3, 4, print K, print. I could do this, and then I get the first names. If I want to just do for K and D, and then I print K, and then I say D of Okay. Sorry. I have to do a for statement first, and then do this. Now I print out first name Wahid. So you print the keyword and then the value to the data dictionary, D of K. These are data structures, and then with arrays is similar, with class is similar. I'm not going to go through the class and other ones because it would not give you any time to do labs. I covered enough for this one. I want you to practice the same kind of environment till like whatever time you get tired, 10:30, 10:05 or whatever. Go ahead, practice it. I'm still staying here. And when I'm just gonna close the session one time so I can just get this record saved. And once I save it, I'll come back and then log in again on the session. You guys are welcome to use the lab and then re-log in if I logged out.